Hello! So, I'm going to show you a little bit more and tell you a little bit more about our new project, which is going to be an acceleration summative project. It's going to be an opportunity for you to explore, develop an experiment, find data, and really show me all the great things you know about acceleration and how it applies to the real world. So, here we go. To begin with, I want you to go over and open up under handouts in Google Drive. Open up J Acceleration Experiment Extravaganza. So under this particular file, it's going to look something like this. And with this, you can see that our main goal here is figuring out how does acceleration affect our real world and how are we able to apply these ideas. So the idea then is, as you kind of look through this, is you're going to be asking a scientific question of some sort, something that has relevance, that has meaning, involving an object that accelerates. Now, an object that accelerates could be anything. It could be anything from an airplane, a car, a person who's running. You pretty much have a ton of opportunities available to really investigate something that you're interested in and ask a question that you find intriguing. So this is a kind of a vague project as far as in concept what we're looking for. But the idea though is that you're asking great questions and that will give you the opportunity to really demonstrate the good things you know. So we'll be working on this project not only this week, but also going into next week. So over the course of the time that you are on breaks, the next few days that you have off, I'd like you to be working on this and making sure that you are collecting data, moving forward, and that you're able to be successful. So now let's get down to the kind of the realities of the expectations. So to begin with, you are able to do this project in different groups. So this group could be no more than 3 people. So no more than 3 people are allowed in your group. But in order to figure out whether or not your group is going to be a group that would be effective and efficient, I'd like you to do a little self-assessment and self-selection. So if you're picking your own group, I need you to go into your learner profile in your ePortfolio. Okay, so you're going to go to your ePortfolio and you're going to go up to your learner profile. And if you remember, we've gone through and you've taken your personality test, you've made your video, you've done all these things, you've learned about your learning styles, some of your strengths and weaknesses as a learner. And what I'd like you to do is use this and also use the information from your peers. And I want you, before you're able to actually create your group, you need to get it approved by me. And what I'd like you to do is tell me, how do your skills and experiences complement each other in order to make your group successful? If you can convince me that that is a good group for you, then I will allow you as a group of no more than 3 to work together. Next, you're going to be looking at a skills piece. And the skills piece is going to come based on your ACT scores. So you're going to go through and figure out what your experiment is going to be all about. What is this going to look like? What components do you want to have? And in order to do that, I want you to go over and look at your ACT or your plan test score specifically. This plan test score will tell you where you currently are and how you are able to grow. So the first thing you're going to do then, in order to investigate Part B, is to go over to your ePortfolio again and go up to Learner Data. Earlier this year, you went to and got your plan test screenshot, a picture of your plan test scores. What I'd like you to do is look at your science score. So if your science score was at whatever range, whatever number you got, this score corresponds with the ACT score that that the plan believes that you currently are at. But the idea is that you're going to be able to push yourself to the next level. So if you currently have a score right here, so check out your score. So in this case, I have a 19 written down. You're going to click on this link. Okay, so you've gone through ACT, you know your plan test score, and now you're going to look at what we call the ideas for progress. So you're within, currently with this 19, you're within a score range of 16 to 19. So you're going to scroll all the way down to the bottom of the page, and you're going to click on the ideas for progress. Now, if you got a score of somewhere between a 20 and a 23, you're going to be clicking on this ideas for progress. If your score was somewhere between a 24 and a 27, you're going to click on this one. So I'm going to click on this 16 to 19. These are the things in this list that ACT believes you can do that you should do in order to push yourself to the next level to improve your science score. So what I'd like you to do is read through these things and specifically highlight aspects of this that you believe you could incorporate into this experiment. So as a group, you're going to talk about 2 to 3 of these things that you want to include in your experiment. Now, we can talk more about this individually, about what do these look like, what do they mean. The idea, though, is things like evaluating models and scientific investigations. Those will be good areas for you to look at. Things like formulating a hypothesis, making predictions, things along those lines. This would be something you'd be able to easily do in your experiment. In addition, this interpretation data piece, as you're looking through it, you'll see that this is looking at if you get a data table or you have numbers or a graph, are you able to make sense out of it? And that would be another area that you would most likely be able to very easily incorporate into your experiment for this. So you're going to find a few things that you're going to want to use as part of your experiment. So you kind of have an idea now of your group, the things you're going to be working on, and what ideas for progress you have as far as how you're going to make yourself better and how you're going to use those skills and incorporate them into your experiment. So now this is the part where we can start to look at a scientific question. And this is what you'll be working on over the next couple days to make sure that you have a good scientific question and a good experiment that you have on the table. So you're going to be going through and figuring out something that accelerates and developing meaningful scientific question. So you're going to read through the rest of these resources of what makes a good scientific question. And as part of this, you want to have an experiment that involves a variable of some sort. So, for example, I'm going to give you an example of a good scientific question that would be able to be used in this kind of context. How does car speed affect the acceleration and braking distance of a vehicle? So you've been looking at some DMV data, and if you had this question as your scientific question, you'd be able to set up an experiment where you'd be able to go and change the speed of the car and figure out through data collection and data analysis how your car was braking differently and whether or not the acceleration was different as you increased your speed. And actually, to kind of show you some of the potential with this, one of my groups last year did do this. So they went through, they used a cop car, actually. They used Officer Fink's car. Actually, Officer Fink was driving. And they were able to go through and figure out how long it took for him to brake at various speeds. So they went from 15 miles per hour, 25, 35, 45, etc. And also figure out about the acceleration associated with that. By doing that, they were able to create a data table where they could actually go through and figure out the braking time. How long did it take? How far did it take for the car to actually brake? And then they were able to do some calculations based off of that. Now, besides just doing a manual data collection opportunity, you also could have the opportunity to use what's called video analysis. And I can completely help you with getting set up for this. This is using Logger Pro in a different way. In this form of Logger Pro, you're actually able to go and insert a video into your file here and do a dot by dot, frame by frame analysis of the motion as the car was moving, as the car was going through and braking. The really cool thing about Logger Pro Video Analysis, if you want to use this tool, is that it allows you to create position versus time graphs, velocity versus time graphs, and really find a way to calculate your acceleration using videos. So basically, your experiment and your setup here is really an opportunity for you to explore in so many different ways. And like I said, this is very open. So let's brainstorm. Let's be creative. What things are we interested in that accelerate? How can we collect data to be able to go and analyze that acceleration? It can be using equations and graphs, using things like video analysis, using our motion detectors like we've used in the past in our lab, and also using manual data collection opportunities too. Now, along with this, there's one other point. If you don't want to actually do your own experiment and actually run your own experiment, you can also go and find a way to collect your own data. So as you're developing your experiment and collecting data, you have this plan of making sure that you're good to go on that front. You could also go and find a reliable data source from somewhere else on the internet, and you can go through and use that data. So, for example, I use the data table from the DMV the braking analysis one where you're changing speed and reaction time. If you found something like that, you'd be able to analyze that too. So now that you've done this, and I know this is a long explanation, but the idea though is now that you've done this, you're going to go over and you've created your experimental plan, you have your scientific plan, and your scientific question developed, and you know how you're going to be collecting your data. Now you're going to be going through as a group and submitting a project proposal. You're going to answer with your group members' names. Why is this group effective? How are you going to be using your ideas for progress to help to develop an experiment that will allow you to get better as a learner? What your scientific questions are going to be, designing and explaining your experiment, data analysis, and now this is the last piece as you're kind of filling this in. You're going to be working on communicating your findings, and the way you're going to do that is by not only just showing me your work with your graphs and your equations, you're also going to be presenting your findings in some sort of a verbal or digital media presentation. Now, this can take many different forms. It could be a public service announcement where you're creating a video to talk about why driving at high speeds is not effective. Or you could create a presentation in front of the class. Or you could do a Go anime video. Really, the world is your oyster. Somehow, though, you need to express and communicate your findings, your experiment, and show me, and this is the key piece, how is our world and society, how are those views influenced because of your object? Why is it important to know that driving at a faster rate as your car has a certain acceleration when it brakes? So why is it that when you drive at faster speeds, it's important for us to realize that it takes more time for you to stop? So find a way to connect this to the real world. Now, once again, this can take so many different forms. So I want you to be creative, start thinking, start developing an experiment, start developing experimental questions, and work with me so that this can be a really cool opportunity. Really, this is what we call an inquiry-based project. It's all about you coming up with something of interest, something that's you're fascinated or kind of questioning or wondering about, and really implementing it. So together, let's show and use all the things we've learned in physics, and now do some really awesome things by applying it to the real world. I'm excited to see what you guys do. Do awesome things. Chat with me. Let me know if you have questions, and I'll talk to you later.